Okay, solving systems with inverses. So let's say that we have an equation that tells us something like this. So first thing I'm going to do is I'm going to set up the matrix equation. Which you guys already know how to do. Then I'm going to find the inverse of this right here. What I'm essentially trying to do is cancel this out. So if I have the identity matrix times xy, that just equals the matrix xy. So if I can get this to be the identity matrix times xy, it's just going to be xy on this side of the equation. And whatever it's equal to will be the answer. So what I want to do is I want to get xy by itself. Or to turn this into the identity. The way that I turn this into the identity is multiplying by its inverse. So I'm going to find the inverse of this. So first I'm going to find the determinant, which is going to be negative 12 minus 1, negative 13, 1 over that. These two switch places, and these two switch signs. Then I distribute. So this is my inverse matrix. So I know if I multiply these two together, it's going to give me this. So I'm going to say times, I'm just going to call this matrix A. I'm going to say the inverse of matrix A. If I multiply this by the inverse of matrix A, I have to multiply this by the inverse of matrix A. When we do this, in order to multiply it, I have to do the inverse first. If you don't do the inverse first, you can't, because this is a 2 by 2 and this is a 2 by 1. So if I do this one first, I'm not able to multiply, which means I have to do this one first. So I'm going to do my inverse matrix, which is 6 over 13, 1 over 39, 3 over 13, and negative 2 over 13, times my solution set, which was 14 and 11. I do this row times this column, so that's going to give me 84 over 13 plus this, which is going to be 33 over 13. That's one spot. Then this row times this column, 39 minus, because it's negative, that's the other spot. That's going to give me 111, 117 over 13. This, I need to get a common denominator, so I'm going to multiply this by 3. So that's going to give me 52, negative 52 over 39. And I'm just going to assume that I can't simplify those. So this is my final answer, which means that x is this and y is this. So I would put it as a point. Whoops, as a point. Got used to writing matrices. And that's the answer to that one. So, what about when I have a 3 by 3? First thing I want you to notice here is that I'm missing the y on this one. That's okay. I'm still going to set it up the same. So I have 1, 1, negative 1, 2, negative 1, 3, 1, 0, negative 4 times xyz equals 7, 4, 11. Now again, I want to get this to be the identity matrix, which looks like this. If I multiply that times the matrix XYZ, it just equals XYZ. So if I can turn this into the identity matrix, it's like eliminating it, and whatever it's equal to is the solution. So I want to get it to be the identity matrix by getting the inverse.